Hello everyone, my name is Luby and now I'm going to demonstrate to you how to prepare the master definition files of waves or the MDW files. And in this tutorial, we will demonstrate to you through the process of creating an example of coupling model between hydrodynamics for the flow module, the MDF file, the one that you have created before, and the wave computation or the MDW files with Swan. To do the coupling, we need to have these two files, the MDF and the MDW files. And to create the MDW files, we need the flow button, and we choose the wave input. Now we are in the main window of the wave GUI. The Delft3D wave input is divided into several data groups like description, hydrodynamics, grids, time frame, and etc. In the data group of description, this one, we can identify this MDW file by giving a description of the project. For example, I'm going to write local model Jakarta wave, but this description is optional, only used for the identification, and has no influence on the simulation itself. So you could just skip this part. Next to the hydrodynamics tab, with the Delft3D wave, we can run a wave computation that use the result from the flow module, but also we can also run the wave for its standalone. But in this demonstration, we are going to do the coupling by using the result. So we check this option, and we are going to select the MDF files that we have created before. Okay, and next in the data group grids, we can define the computational grid that we are going to use and its corresponding files that we need to specify. And here I'm going to import the grid. Go to the bathymetry tab, and we're going to select the bathymetry data that corresponds to the grid that we have chosen before. In the spectral solution, here we are going to specify the wave propagation in the spectral space in each geographical grid. In the nesting tab, if we are used in nesting, it's used to import all the considered grid to make the nested ones. But for this demonstration, we are going to use the default setting for the spectral solution and the nesting. Next, in the hydrodynamics tab, we specified which component result from the flow module. And for this coupling, we are going to use button extend for the water level, current, and for the wind. It means that the wave simulation will consider it and use the data of water level, current, and wind for the wave simulation, but it won't affect or it won't change the final output of the flow module. For the bathymetry, we won't use the data from the flow module because we use the different grids, and we already specified the bathymetry files that we are going to use in this step before. In the data group of time frame, in this demonstration, we want to specify and use the default setting for the water level correction. In the boundaries, it includes the wave condition at the boundary of the first computational grid are prescribed. But in this demonstration, we want to specify this further. And in the data group of obstacle, we can specify the obstacle that might interrupt the propagation of the waves. But in this demonstration, again, we want to specify this further and use the default setting. In the data group of physical parameter, we can specify a number of physical parameters that are going to be considered in the simulation. In the subdata constant, we can assign a value to some general parameters like gravity, water density, and the others. In the processes, in the processes subdata, we can select the physical processes in this one. For example, the type, dissipation processes, nonlinear wave interaction, diffraction, bottom friction, and etc. In the various subtab, we can switch on and off which wave propagation in spectral space and several physical processes that we are going to choose. But we are going to leave it as it is. In the data group numerical parameters, we can modify parameters that will affect the stability and accuracy of the numerical computation. And in the data group of output curves, we can specify an output curve at which wave output should be generated by the Delft3D. But this demonstration, output curves will be defined, and in the data group output parameters, in here we are going to define the output and also determine which grid, flow grid or the wave grid, that is going to be written and to which extent the computation should be monitored. For the computational mode, we choose the non-stationary one. The non-stationary one, if we want to differentiate the time step between the wave and the hydrodynamic module. But this option will also affect the computation time, which will be longer. For example, I'm going to write it as 60 minutes or 120 minutes. And then we also check the write and use hot start file. Oh, okay. It's 60 minutes. We are going to write and use the hot start file to write and use the swan restart file. So the entire wave file at the end of our computation can be used as an initial condition in the next subsequent run. So it will be continuous. And next, for the output, we select the Jakarta for wave grids, and the interval we also input it as 60 minutes. Within this data group, it is also possible to select the output location for which the 3D wave produces wave output that is directly obtained from the swan. For example, the 1D spectra or 2D spectra. Next, in the additional parameter, we could skip this one because we already input the additional parameters for the meteorology like the wind and the pressure in the MDF files. And if we want to save the data we have input, we go to the file item in the menu bar. We choose the save as and write, for example, Jakarta 1. Make sure the extension of the file is in the MDW. Save. Now, after this, we are going to do the running together with the MDF files that we have created before. See you on the next step.